Welcome everybody to another exciting episode of Let's Make a Game Together. My name's Dave, and in this tutorial series we are going to be creating a new game called Super Keegan. What is Super Keegan? Super Keegan is a mobile game based off a true story, a buddy of mine, and it's basically a game where you're this little character here, Super Keegan, and you move left and right and you collect tokens and you get hurt by logs. Now, seems very simple, but the beauty of this tutorial series is we add lots of juiciness. That's right, we add things like camera shake, we add things like, invincibility, we add power-ups, we add like big logs that are instant kills, and we add cool sound effects. And this game is a really good start for anyone who's getting into serious commercial game development. If you want to make some like serious mobile games and you don't know where to start, this is a really good start. Now, the exciting thing about this game is every line of code, every single thing I type into the keyboard is completely royalty free. You can take it, you can copy it, you can do whatever you want, you can upload it in your own game, you can copy this tutorial from start to finish if you want to, and have a reskin it to like a Space Invaders theme or whatever you want, and put it on the App Store, and I will be completely fine with it. In fact, I actually would applaud you for doing that because not many people can actually finish and upload a game. It's actually really, really hard, as you will see. A couple of things to note is you will need a Macintosh computer to do the uploading to the App Store. You won't need it for any of the actual game development, and you will be able to upload this to an Android store. It'll work completely fine on Android devices, or most of them anyway. I'm not actually sure about specific hardware, but you will need an Apple device to do the Apple portions of uploading it to the App Store and things like that. You'll also need to install Xcode, which is Apple's developer kit. We'll talk about that way further on down the track, and this tutorial will not cover any artwork or basically any music, but basically just the coding and the project setup and things that you have to do inside of Unity is what this tutorial will cover. I'm no artist and I'm no musician, but I'll touch on those things just very lightly, but specifically this is just a coding tutorial. It's really awesome to hear that so many of you guys are getting so much out of this tutorial series. Thank you so much for liking, favoriting, subscribing in the last series, and I hope that you guys enjoyed this one just as much. If you do want to support this channel and you want to support this series we're doing now, the game is available to buy from the App Store. Every single person that buys it, I will be giving you a thumbs up mentally over these sound waves. It is really awesome. It does seriously help out this channel and helps me produce more videos quickly.
Yeah, dude.
And as a special bonus, anyone that actually buys the game to support this channel, at the end of this tutorial series, whoever has the top score in Game Center out of the subscribers of this channel, I will be sending him this book. It's called Masters of Doom. It was a book about the early games of id Software and how the creators of Doom did some crazy things like stealing their computers on the weekend from their game company and bringing them home and working on their own game. Really inspirational book, guys, and I will send this away to whoever has the top score at the end of the final video, whatever day that is. Whoever has top score, send it away. You just got to prove it by having a Game Center account. So, just another way to say thank you guys for supporting this channel, and love yous. Awesome. Peace. Okay, so we can create a new project. Just go to New, and I'm going to call I'm going to choose the folder first, and it's going to be in my tutorials folder. I'm going to create a new folder called Super Keegan. Create that, choose that folder, and name the project Super Keegan. You can call it whatever you want, obviously, whatever theme you're going with. And we want to click 2D, and we just want to create the project. Okay, so while it's booting up, we can think about what we're doing. So the first thing we want to do is we want to go to File and go to Build Settings. And we want to change it to iOS because that's what we're going to be targeting. And we want to click Switch Platforms, and then straight away it goes to iOS. And just because we're here, we want to just click the Add Open Scene, and it's going to ask you to save a scene, in which we can just click Main. Cool. So now you'll see the scene has popped in our Assets folder, and then we can get started. So first off, the scene view shows a tall aspect ratio, which we're not going to be working with. We're actually going to work with the wide. So we can do iPhone 5 wide. Now this is just aspect ratio, so that's 16:9, and that's totally fine. And that works really well. You might decide that you want to do yours tall ways, and that's totally fine as well. And yeah, and it's all totally fine. Okay, so first things last, we want to create a folder structure. So create a new folder called sprites. To handle our sprites, create a new folder called scripts, and that'll do us at this stage. And before we could actually get any artwork in the game, it's very important that you prototype what you're going to do. So that means testing out the physics, testing out things, getting a general sense of what the game is going to be and how it's going to work before you start investing in artwork. Because take it from me, you can get really inspired about an idea, and the funnest thing to do is start working on the artwork. But the problem with that is you may realize that the artwork is totally offbeat to what the gameplay actually feels like, and it causes complications. I'll leave a link in the description to a really good talk by Jonathan Blow in which he talks about prototyping if you're interested in that. Okay, so what we're going to do is we're actually going to open up Photoshop. And in Photoshop, we are just going to create a simple cube. Square. And this square we're going to use as our main prototyping tool. We're just going to call it square. And did I spell it right? Oh. Yep, and then we want to just make it 100 by 100. Let's say 300 by 300, just so it's a bit more resolution. Press OK. Creates a blank canvas. Now you don't need Photoshop to do this. You can use any program because we're literally just creating a cube. So we're just going to go to the white color, dump it in there, go File, Save As, and let's go to find your folder, Tutorials, Super Keegan, Assets, Sprites, and just save it there. And Photoshop file is just fine for Unity. Cool, so that is done, and so we can start working straight away on our physics and code, and we haven't got any artwork in our game, which is exactly what we want. So inside of sprites, we want to go to it, make sure it's all imported correctly. We want to change this to point because that's just what we're dealing with at the moment, and I like to use 16-bit or true color. It doesn't really matter at this stage, but just out of habit. Cool. Create a new empty object, and we're going to call this scene. Make sure it's at 0, 0, 0, and rotation is 0, 0, 0, and scale is 1, 1, 1. Doesn't matter too much with the scale, but the other things are important. Create a new empty game object and call this floor. And then we're just going to nest that inside the scene. Make sure both floor and scene are both at 0, 0, 0. This is very important to make sure everything is all the same. And then on the floor, we are going to add a sprite renderer. And we're going to drag our sprite over to the sprite section. Cool. Then we can use the transform to adjust it down to the bottom. And we can actually scale it to, say, 10. And we can adjust the color to whatever color you want. Maybe the dark kind of a green color. That's what I like personally. Fantastic. And then we want to add a box collider 2D. Make sure it's 2D because we're working in 2D. And you'll notice that it puts the box collider perfectly around it in the scene. And then we have literally got a floor with a collider. So we're doing pretty good so far. And next thing we want to do is create a player. So we want to create empty. Change the name to player. and make sure it's 0, 0, 0. It's like what we like. We're going to add a sprite renderer. We're going to drag the square over to the sprite renderer. Remember, this is all just for prototyping. We're going to make it like 0.3, 0.4 maybe. There you go, that's a good number. And we're going to add a box collider 2D, and we're going to add a rigid body 2D. Rigid body is in control of physics. It sets like the mass, the how much drag there is, the gravity scale for the object. Any constraints, we probably want to freeze rotation on the Z and freeze position on the... No, we don't actually want to freeze position. That's all good. So we press play. We have a white cube that collides with a green platform, and that is pretty good. Alright, we're done. No, just kidding. Okay, so now we've got a basic scene set up. We've got our white cube player and our green floor on a blue background, and we're only probably 5 minutes in, and we can start our scripting. So if you go to scripts, and we're going to create a new script in this folder. I think it's really important that that you keep the entire project organized. So it's really important to keep scripts in script folder and sprites in sprites folder. Otherwise, the project can feel cluttered and complex, and you want to make sure that it doesn't get that way, because otherwise, there's nothing more than that kills creativity is working out problems that are just simple problems that you shouldn't have had in the first place because of unorganization, or you've changed a variable here, or you've done something there, or you've deleted something that references another class. Like it's better to be more organized than not to be organized. So let's get on to the player movement. If we right click here and we go create C# script, and we'll call this P underscore move. P standing for player, and double click that. It should open up. Awesome. Okay, so what we want to do is we want to create a new integer. Now, I just want to explain some of the theory first. I'll just zoom in a little bit for you. Some of the theory first, so we're on the same page. You could create it so that the player moves back and forth like this, and dodge things, by just moving left and right. But I think it's actually probably nicer, especially for like the iOS, is just to make it so every time you tap the screen, it moves one space to the right. So it'd be like 1, 2, 3, 4, 5, or -5. It just moves more rigidly. So the player has more of an ability to precisely choose where to go in order to dodge or collect the things he wants to collect, or dodge the things he wants to dodge. So to do that, I'll open up this class. I hope that's not too big, and we're going to create a new variable. It's going to be private. It's going to be an integer, and we're going to call it xPulse. Make sure the capitalization and uncapitalization is make sure you spell the variables exactly the same. That's very important in coding. And then we're going to delete the start method because we don't need it. And we're going to write in the update method if. Now, there are two things we can do here. We can create iOS inputs straight away. But the problem with that is we can't actually test that in Unity. So the first thing you want to do is probably create keyboard inputs, and then later on, when you're ready to test it on an iOS device or an Android device, you can do that by just changing the code in here or adding the code. So for now, we're just going to do keyboard inputs. So we'll say input.get button down, and we're going to ask for horizontal, and then inside of that we're going to say if input.get access equals horizontal. Oops, sorry. Is greater than 0. Then we can say x pos plus plus. And then we can copy this line of code, add it underneath this curly brace here, and say if it's less than 0, x pos equals minus minus. And then just so we can test what we're doing, if we underneath this if statement here, if we just write a simple line of code, debug.log, and then write in x pos, that should run fine. If we go to the player and we add the p_move and I press play, if you look into the console, you'll see that we got 0, 1, -1, -2, -3, and if I press right a few times, right, it the number ends up going up, and press left, the number ends up going down. And that's exactly what we want. Cool, so it's working fine. But instead of this debug.log, we can create a new method from here. Well, sorry, call a new method from here. And I suppose what we want to do is maybe make the method first. So we'll say void. Void basically means nothing. Well, it means void, like nothing, because you can have other like you can have like I enumerators and things like that do more specific tasks in C#. But for our purposes, we just need void at this stage. Move player, and so this is going to be called every single frame. If we put that in update, just move player, then it's going to be called every single frame because update's called every single frame. Awesome. Alright, so then we want to create a new variable, vector2, call it player pos, standing for player position, equals GameObject.transform.position. And then we can write player pos.x equals x pos, which stands for x position, which is our variable up here. and then we can just do the translating, which is literally just GameObject.transform.position. What does that equal to? It equals to vector2.lerp. Actually, we want to get rid of this bracket. We don't need a bracket. Sorry, I got a bit confused there. And GameObject dot. So what this is doing is it's saying, well, the GameObject's transform position. So this GameObject, because this script is on this GameObject's transform, which is this section here. Its position, which is this section here, X, Y, and Z. So if you move that, you'll see the position changing. Saying is GameObject.transform.position, so it's referencing that. Well, what is that? What does it equal? Well, it equals a lerp, and a lerp is a linear interpolation, I think how you say it. It basically smoothly transitions from one spot to another, one vector to another. So, where do we want it to lerp from and to? Well, if you write this and go, it'll actually tell you here, it says, well, it needs vector 2A, vector 2B, so we know it's going from A to B, and then how fast we want to do it. So we can just say, well, we want to go from GameObject.transform.position to player position. Yep, comma separating all these things, and we want to do that, let's say 10 times time dot delta time. Cool. And that is a fully functioning code. I think that'll work totally fine. So let's give that a whirl. No errors have come up in the console. That's fantastic. And we press play. Character falls down and he moves from left to right. Cool. So we have a moving character now. Every time you tap, he moves from left to right. Awesome. Alright, well, I just actually realized something. If we go to our player, I just realized that we don't actually need the rigid body. And it's just going to, like, you can leave it on there. There's nothing wrong with leaving it on there because the game works totally fine. But I just realized that we don't actually need it. So if we don't need it, it's probably better that it's not there. So if we remove the component, the game will still not have, the character will still stay where his positioned, him or her, or the player's position. But it won't move down, but that's okay because we don't actually need it to move down. Because it's not going to move up or down in the entire game, it's just going to stay on one platform. So we essentially can literally just drag him down to where he sits, just to where we want him, maybe there, and then the game works completely fine. Pressing left and pressing right, and the game works great. And the player object is actually a lot less heavy on iPhones or whatever. You know, there's not calculating physics for that object. So that's fantastic. All right. Well, what we want to do is we want to create another folder, and we want to create a folder, and we're going to call it prefabs. And we want to drag the player into the prefabs folder. What this does is create basically this player object now is an instance of this prefab. So if you adjust anything on here, it'll be different for the player, and you can see that it is a prefab by the fact that the text here is blue. Alrighty. So what we probably want to start working on now is the object spawning script. So we're going to create a new C# script. We're going to call it object spawner. Yeah, it sounds like a good name. Open that bad boy up. And open that up there. Cool. Alright, first things last. I know it's annoying that I keep saying that, sorry. Public game object. So we want to create a public game object variable. I'm going to call it token, or money, or coin, or whatever you want to call it. But this is going to be the thing that you collect. I like to call them tokens. Another one called public game object tree. Alrighty, we don't need anything in the start function method, so we should get rid of that. And in update, we can get rid of that because it's ugly. Well, I don't like it anyway. And actually, first of all, we should probably create some timers. So, write another private float, and we'll call it token timer. And let's actually equal it to 2.0, and you're going to put F on the end because it's a float. Copy that, paste that, and we're going to call this one tree timer, and give that 2 as well. And then all we want to do is say token timer minus equals time.delta time, and same thing for tree timer. So all that does is it means that the tree timer and the token timer are going to go down by time.delta time every single frame, which is what we want. So the timer is to go down, and then we can just write if token timer becomes less than 0, run this method. Run spawn token method. And same here. Tree timer is less than 0. Run spawn tree method. Alrighty. So maybe we should first handle the spawn token. So create a void spawn token. Something that I never understood when I first started programming was where people get their names from. Literally, this is just a name that helps me understand what the list of instructions are going to do. So I'm creating right now a void, which is a method, like a method or a function, depending on who you talk to. And it's basically a list of instructions. And what do we want these instructions to do? Well, we want them to spawn a token. So we can literally call that whatever we want. You could say spawn token because David is awesome. And that would be totally fine, but we're not going to call it that because that would not make any sense. We're going to call it spawn token. And then we want to create a new game object. And call it toc and for token. And what is the game object going to do? So right now we're creating a game object variable, and what's that variable going to be equal to? Well, it's going to be equal to an instantiated token at a new vector2 at random.range minus, let's say minus 6, that sounds okay, to 6. Actually, we should probably check that. Let's go to our player. There's going to be some errors come up at the bottom, that's okay. So if the character goes to minus, we want to have some pillars on the side, so minus 6 seems fine and 6 seems fine. So minus 6 and 6. And then at what y? Well, we want it to probably be 10. Let's have another look. How far up does the player have to be before he's off the screen? 6. Alright, so that's... So 6 is off the screen. And then quaternion.identity, it sounds impressive. Basically just means quaternion.identity basically just means whatever the prefab's at, like whatever rotation, then instantiate it in that same rotation. Cool. Alright, so we've created a new game object which instantiates that. Then we want to say, well, token timer is equal to random.range 0.5f to 2.5f. Alright, fantastic. And then we want to just say 2 no, let's just leave that for now. Alright, so what that does is it runs every time the token timer gets down to 0, we want to call this method, spawn token. And then when it gets to 0, it runs this method, and what does it do? It creates a new game object, and then it resets the timer to some value between 0.5 and 2.5, so it's always different. That adds a little bit of procedural fun for our game, I guess. A bit of randomness, random fun, I suppose I should say. And the game object token still needs to be set up, but we haven't actually created that game object yet, so we're actually just going to finish the code, do the same thing, void spawn tree. Whoa. add that there, yep. And I suppose we can actually just copy this. And we can say TRE and tree. So make sure it's the same as this game object. So you're instantiating this tree at a new vector 3. But this time it'll probably have to be a bit higher, probably let's say a 10, because the tree is a bit longer. Same containing identity as a game object. We want to change this token timer. We want it to be tree timer, because that's what we actually want to change. And then underneath this, we are going to do something a little bit tricky, a little bit fun. We're going to say TRE dot get component, and we're going to say rigid body 2D dot gravity scale equals random dot range 1 to 3. So that means that each tree is going to fall at different speed, and yeah, and that should work completely fine. So if we go back into Unity, it's going to say, oh, the variables aren't assigned, problem, but that's okay. We're going to create a new game object. We're going to do, I like to just do dash scripts, big caps, stick it up the top so it never gets lost, 0, 0, 0, for sake of OCD-ness. And we're going to add the object spawner. And it's asking for 2 game objects. Now we don't have those game objects yet, and we're still prototyping at this stage, so we can literally create new empty token, and let's add a sprite renderer to it. And the only sprite we do have is the default. We're going to say 0.1, is that too big? No, 0.1 is a good size. Let's change the token to a nice, not a disgusting, like a nice yellow. And let's add a box collider 2D to it, and let's add a rigid body 2D to it, so it actually falls. And then we want to drag this into the prefabs folder and delete it out of the hierarchy, and do the same thing for the tree. Empty tree, add a sprite renderer, add the square. The square really does come in handy. Add that as 0.2 to 5. Let's say 2.5, and we're going to say the height. Leave that at a 1. Seems fine. Let's make it a brown color. What's brown? That's a good tree color. And add a box collider 2D and a rigid body 2D. So in the script where we access the rigid body and we access the gravity scale, that's here. So if I say copy, paste that, and then move that to the side, move them both up, and we make one have a gravity scale of 1, and we make the other one have a gravity scale of 3. When I press play, you'll notice they'll fall at different speeds. Adds a little bit more of a challenge to the game. So we're going to delete that other tree, and I think that's everything we need, and we can click and drag it into here. So now we got 3 prefabs. You got the player, you got the token, and you got the tree. Under scripts, you can see Unity in here spazzing out because the variable token and object spawner has not been assigned. That's alright. Go to scripts, drag over the token to the token folder section, drag over the tree to the tree in our object spawner script on the scripts game object, and then when we press play, well, let me delete the tree first. When we press play now, the game should spawn trees and tokens. Let's see if it works. Well, there's a token, lands there. It's spawning lots of tokens. Wonder what's happening with the trees. Is it? Okay, it should be. Oh, we didn't call the tree function, the spawn tree method, after it gets to 0 here in update. I'm so glad I didn't have to pause the video and Google that. Alright. So now it should spawn trees. Yep, and it does. The trees stand there and are totally in the way, and they bounce everywhere. It's probably not what we want. But we got some cool gameplay. They don't hurt the enemy yet, they don't do anything, but at least we got a game that you can collect tokens, kind of. You can't collect them yet, but they spawn, and random trees spawn, and random tokens spawn. If you see what I mean, like now I'm in the exact right position that if I moved to the right, I would have missed that if there wasn't such a... Let me just show you again. I'm right in the middle. Nothing will touch me unless it falls at 0. Oh! See, I dodged it just because I tapped it once. And that's the kind of gameplay we kind of we want, because it means that the player has like really accurate, like if they stuff up, it's on them. And that's kind of what we want. It looks pretty fun, eh? Alright guys, well join me for the next video in which we'll go more into depth with collecting, scores, things like that, or I don't know if we'll do that next video, but join me next video, like, subscribe, favorite, send it to a friend, tweet to me, I'll always try and reply. If you've got any questions, leave them in the description, and I'll see you next video. Peace.